Hi, so in this video, what we're going to do is we're going to differentiate the function, the natural logarithm, so the function ln of x with respect to x. And to do this, instead of using the first principles definition of differentiation, we're just going to use the previous video to help us out with this one. So from the previous video, what we found is that when we differentiate the exponential function, we just get the exponential function. And that's a result that we can prove using any definition of the exponential function that you like. And we're just going to use this to help us out with differentiating ln of x, so the natural log of x. So we know that ln and the exponential function, so these two functions are inverse functions. So we know that when we do the exponential function of the natural log function of x, we know that's going to be x. And we know that when we do the natural log, or take the natural log of the exponential function of x, we know that that is just going to get us x as well, because these are inverse functions. So we're going to, again, use that to help us differentiate ln of x. Okay, so let's say we want to differentiate ln of x. So the trick that I'm going to do is I'm going to call y, so y of x, ln of x. So I'm going to define ln of x as this function y of x. And what we're going to do is we're going to take exponentials on both sides. So take the exponential function on both sides. And when we do that, we get e to the y of x up there. And this is equal to e to the ln of x. But again, from this previous slide, we know that the exponential function and the natural logarithm function are inverse functions. So e to the ln x is just x. So we've got e to the y x just equals x. Okay, great. So now the next step here that we're going to do is we're going to differentiate both sides with respect to x. So we're going to differentiate the first side with respect to x, so e to the y x with respect to x, and differentiate x with respect to x. Okay, so this right-hand side is quite trivial. So we know that when we differentiate x with respect to x, we just get 1. So this left-hand side, again, I'm just going to copy this out again. So d by dx of e to the yx. So to differentiate this, so really this is implicit differentiation, which is another term essentially for the chain rule. So if we want to differentiate this e to the y of x, we can just use the chain rule that we did in one of my previous videos. So we want to differentiate with respect to x, e to the y of x. So this is again a function of a function, which means we're going to use the chain rule. So this is a function of a function of x, and we'll call these two functions f and g. So in this case, the f of x is going to be this this e to the x, so this exponential function, and this g of x is going to be the y of x. So using our chain rule, we know that this derivative up there is going to be d of f of g with respect to g multiplied by d of g of x with respect to x. Okay, so if we start with this second part there, so the dg by dx. So when we differentiate g of x with respect to x, well, that's just going to be the derivative of y with respect to x. So dg by dx just equals y, dy with respect to x, because the g of x is the same as y of x. So that's the second bit dealt with. And this first bit, so we want to differentiate f of g with respect to g. Okay, so we know that f of x is equal to e to the x. So that means that f of g is e to the y, because g is the same as y from there. So f of g is the same as f of y, and f of y must be e to the y. So when we differentiate f with respect to g, well, that's just the same as differentiating f with respect to y. And when we differentiate e to the y with respect to y, well, we know from the previous video that when we differentiate the exponential function, we just get the exponential function itself. So this is e to the y. And so therefore, what we can actually conclude from this, just make the writing a bit smaller. So we know that df by dg is e to the y. We know that dg by dx is dy by dx. So therefore, the derivative of e to the y of x is going to be dy by dx multiplied by e to the y. Okay, great. Yep. So we know now that this derivative of e to the y of x is going to be e to the y multiplied by dy by dx, because this is the same as this over here, and we've just worked that out. Okay, great. So now let's write this out again. So e to the y by dy by dx equals the number 1. So let's divide both sides by e to the y. So we're going to get dy by dx equals 1 over e to the y. So now if we remember, we said a couple of pages ago, let y equal ln of x. So we know that y equals ln of x. And so therefore we know that e to the y must be equal to e to the ln of x, which is just x. And again, that would be on this slide here. So e to the y of x is just x. So now we can plug this result and this result into this part over here. So what we've got then is that the derivative of ln of x with respect to x is the same as 1 over e to the y. The e to the y is just x. So this is 1 over x. And so we've proved the result that when we differentiate the natural logarithm of x, so d by dx of ln of x, this is 1 over x. And that's the result in this video.